Hello students, we're going to be working on section 4.1. This is the Cartesian coordinate system and reading graphs. So we're going to do a lot of graphing in this chapter. And so good notes are really necessary for this particular chapter, and maybe some student lab time and talking to Mrs. Stubbs personally. We can do some Zoom meetings. So here we go. First section's pretty easy. So we are going to talk about the Cartesian, named after a man by the name of Cartet, actually. And he's the one who kind of came up with this Cartesian system. If anybody grew up in Ephraim or a town in Utah, generally your town is set up on what we call a Cartesian plane, where there is a main street and a center street. And those are the two like X and Y axes. And the homes are kind of built on ordered pairs coming off of that. So just remember, we talked about this a little bit before, but in a number line, there is a one-to-one correspondence between a point on the number line. It also applies to a point in a Cartesian plane. There's a one-to-one correspondence between points in a plane and ordered pairs of real numbers. The ordered pair 2 and 3 will only exist right here and nowhere else. Okay? So that's what it's saying. There's just a one-to-one correspondence. Now, what it wants us to do is to graph the set of ordered pairs. So first thing we need to remember is that a Cartesian plane is made up of a x-axis and a y-axis. And when we graph on there, we're using things called ordered pairs. And the first one is always x, and the second one is always y. And basically, you start always at 0, 0, the intersection of the two lines. And then it tells you how you're going to be moving. So this says go left 2 and up 1, or to go to the left 2 on the 2 number line, on the x number line, but go up 1 on the y, and it's this point right here. It's kind of like driving a car. I'm going to go 2 blocks left and 1 block north, or 2 blocks west, 1 block north. Okay? And so we're gonna practice plotting all those points. But remember, we have an x number line that starts at 0 and has the negative and positive going each way. We also have a y number line that's vertical, okay, going that way. So let's clear that, and let's just go ahead and graph some of these. So we start at the origin, and we move 2 units left and 1 unit up. So we're going to look at how these are done. So here was the point, 2 units left, 1 unit up. For the other points we could move 0 units left or right, and then 2 units up. This one's 1 unit right, 3 units up. This one's 1 unit left, 4 units down. And this is 1 unit right, or 2 units right, 3 units down. So left is always going to be negative, right is positive, up is positive, and down is negative. All right. So you could just practice that on your own, but here's another one where we get to practice graphing them. So in this case, right here, we do 1 left, 3 up, 0 left and right, 1 up, 1 right, up or down 1. So over 1, down 1. Basically, that's how that would look. This one would be over to the right 2, down 3, over to the right 3, down 5. So let's look at how those work. And notice something unique about these. What do you see kind of going on? What's happening if I play connect the dot? What am I actually making? If I could connect the dot better than I did, I'm going to be making a straight line there. This particular set of ordered pairs creates a straight line. So we're going to say determine which of any of the ordered pairs satisfy the equation. When I say satisfy, I mean makes it true. So what you do, here's our equation, and we're going to substitute into our equation right here these values. 0 goes in for x, -2 goes in for y. If it's a true statement, then this is what we call a solution to this linear equation. So let's go ahead and look and see. So the first thing that we're going to do is substitute 0, 2/3, and 2 for x. You can see that 0, 2/3, and 2 for x. And then we're going to see, and then we'll substitute the y values in. So here we go. If x is 0 and y is 3, will this satisfy the equation? And we notice that if we go back and let's look at this, if I put 0 in here, 3 times 0 is 0. And if I put a negative 2 here, I get a negative 2 equals a negative 2. This one is yes. If I do this one here, y in this case is 0, so does y equal 2/3? And we're just going to times it by 3 minus 2. Well, 3 times 2 is 6. 6 divided by 3 is 2. Does 0 equal 2 minus 2? 0 equals 0. Yes, so this is true, or this is a solution. And then we'll try our last one. I'm going to substitute the 2 in for wherever there's an x and the 5 for where there's a y. So instead of y, I'm going to write 5 equals 3 times 2 minus 2. And then I get, does 5 equal 6 minus 2? Does 5 equal 4? No, so this is not a solution. Okay, so that's what we see here. But 2 and 5 does not satisfy the equation. Okay, here's another one. This time we're gonna pick any value we want for x, and we've already actually picked those for us. And we're gonna substitute it in and solve for y. So this 0 will go in for x, so I'll redo it as 2 times 0 plus 3y equals 12. And now just using our skills of linear equations, 2 times 0 is 0, so 3y equals 12. And then I'm going to divide by 3, and y equals 4. So if I have the ordered pair 0 for x and 4 for y, it is a solution to this. And we could try the same thing for 3. Put 3 in for x, 2 times 3, plus 3 times y equals 12. Well, 6 plus 3y equals 12, or 3y equals 6, because I'm going to subtract 6 from each side, and then divide by 3, and y equals 2. So I could say the ordered pair 3 and 2 works and satisfies that equation. And then this time it gives me a y value, so I can say 2x plus 3, and y is 0, so I'll put 0 there, equals 12. Or 2x equals 12, because 3 times 0 is just 0. And then if I divide by 2, x equals 6. So 0 or 6 and 0 also is a solution to that ordered pair. And then finally, the last one, we're going to try a negative 2 in for y. 2x plus 3 times a negative 2 equals 12. 2x minus 6 equals 12. If I add 6 to each side, I get 2x equals 18, and x equals 9. And so I could put a 9 here. And so when I'm given one of the ordered pairs, I can substitute it into the equation up here and solve for the other one. Now, these are all solutions, and if we were to graph them, they would form a straight line because of these are linear equations. So they do that here, and they come up with the ordered pairs that we needed. And they show us the ordered pairs. Now, sometimes you're going to see them in boxes like this. I prefer to write my boxes like a T-chart like this, X on here, Y, because then that makes the ordered pair already. This one, you're making me an ordered pair, but you kind of have to flip it. But if I put 0 in for X, what is Y? Well, 1 minus 2 times 0. Well, and that's y equals 1, because 2 times 0 is just 0, so y equals 1, so we would put a 1 here. Now, if we wanted to find the other one, where it tells us, well, what if y was 3? My pen is having issues with me. Okay. What if y was 3? Clear that. What if y was 3? Let's put that in and see what we get. So, well, first they're going to do it. So what if y is 3? So 3 equals 1 minus 2x. We're going to subtract 1 from both sides. So 2 equals a negative 2x. Then we're going to divide by a negative 2 right here. And we're going to get x equals a negative 1. So we have the ordered pair a negative 1 and 3. Because remember, the x value always comes first. Then we could try it for 1/2. And a negative 2 times 1/2 is a negative 1. 1 minus 1 is 0. So we'd have the ordered pair right here. X was 1/2. Y is 0. That's the ordered pair there. And what if x was 5? We'd put that in there. 1 minus 10 is a negative 9. So we'd have 5 and a negative 9. And you can see how they have completed the chart. I just like to see them as ordered pairs. And so I use the XY vertically like this and not horizontally like that. However, either way is correct. Although this discussion is related to ordered pairs of real numbers, most of the examples use ordered pairs of integers. This is because ordered pairs of integers are relatively easy to locate on a graph and relatively easy to read from a graph. Ordered pairs with fractions, decimals, or radicals, irrational numbers, must be located by estimating the position of the points. But you do need to realize that they could be fractions, they could be decimals. The precise coordinates intended for such points can be difficult or impossible to read because large darts must be used so that points can be seen. So that's why we usually just use integers in this, but you're going to find that there are also going to be some fractions. So here are two graphs. They are straight lines. So we're just going to look at the picture. And if you notice, I could probably put along this line a whole bunch of little points. In fact, I could put infinitely many points along this line. But we're going to look for just 3 points. And so the way you can do that is to just kind of count over 1, up 1, or actually over 1, up 2. There's a point. Hold on 1 second. We're going to pause for a second because I do have to take this particular phone call. 1 second. Sorry about that. Okay, so we have these two straight lines. It just wants us to pick 3 points. So I'm going to just put a point, and I'm going to try to do it so it's like right at an intersection of like the smaller grids. Back it up here. So I'm going to pick a point right here. And if I count, that's 1, 2, 3 to the right, and 1, 2, 3, 4 up. So that would be the ordered pair 3 and 4. I could pick a point right here. That's 0 to the right and 1 up. And then I could pick a point right here. If I pick this one, that's 1, 2, 3 to the left and 2 down. And so it would look like that. That's a comma right there. All right. So I have done that. Here I could pick a point, and I like right where it crosses the y-axis. I'm going to call that, there's a special point. It's called the y-intercept, or where it crosses the y-axis. So it's 0 points, or 0 left or right, but it's 1, 2, 3 up. And over here, I'm going to look, and I'm going to like, well, here's another point that I can pretty well see, maybe. And that would be maybe over 1, up 1. And then down here's another point I can kind of see. And maybe that's over 1, 2, 3, and down 1, 2, 3. It's positive over, sorry, but it's down 3, like so. So I have just identified some points. They're going to find some other ones. So which of these, we're going to do the practice problem. So pause your video and go ahead and give it a try. All right, we're just checking to see if these points are a solution, and we do that by just substituting in. So in for the place of x, I'm going to put a 5, so 3 times 5. And then for the place of y, I'm going to put a negative 1 minus 1 equals 14. Well, 15 minus 1 is 14. 14 does equal 14. So on this one, I would say yes. Here's another one. 3 times 4 plus 2, does that equal 14? Well, 3 times 4 is 12. 12 plus 2 is 14. 14 does equal 14. So this one's a yes. And on this one, 3 times a negative 1 plus 17. Does that equal 14? Well, a negative 3 plus 17 equals 14. And 14 equals 14. So it's yes on all three of these. On the second one, we're going to determine if, or we're going to find the missing one. So we're going to be detectives. We're going to substitute this in for X and find its Y partner. So let's go ahead and try that. All right. 0 into 3x, so 3 times 0 plus y equals 5. Well, that's just 0, so y equals 5. So I found its partner. Now I'll do this one. 3 times 1/3 plus y equals 5. Well, 3 times 1/3 is 1, so 1 plus y equals 5. Subtract 1 from each side, and I get y equals 4. And the last one, this time we're doing y, so I'll have 3x plus 2 equals 5. Using my detective skills of adding, subtracting, multiplying, dividing, I'm going to subtract 2. And I get 3x equals 3. Now I'm going to divide by 3, because remember, I want a positive x in the end, and x equals 1, so I can put a 1 right there. And that takes care of those. One last one, fill in this chart. All right, so if I put 0 in for x, y equals 2/3 times 0 plus 1. Well, 2/3 times 0 is 0. So y equals 1. So I could put a 1 here. On this one, if I put a negative 2 in for y, negative 2 equals 2/3 x plus 1. So the first thing I want to do is clear that fraction. I'm going to multiply both sides by 3. 3 times a negative 2 is a negative 6. 3 times 2/3 is 2x. And 3 times 1 is 3. Then I can solve by subtracting 3 from each side. And a negative 9 equals 2x. So divide by 2. Not a negative 2, that was a positive 2. And I get x equals a negative 9/2. Sometimes it doesn't always turn out pretty, does it? How about if x is a negative 3? So y equals 2/3 times a negative 3 plus 1. Well, 2 times a negative 3 is a negative 6. A negative 6 divided by 3 is a negative 2 plus 1. That should be a 1, not a y. And so y equals a negative 1. And finally, our last one, what if x is 6? So y equals 2/3 times 6 plus 1. Well, that will reduce down to 2. 2 times 2 is 4. 4 plus 1 is 5. So y equals 5. And I have come up with the set of ordered pairs that they would be. They would be 0 and 1, negative 9/2, and a negative 2, negative 3, negative 1, and 6 and 5. There we have our solutions. So good luck on your homework. This is just about plotting and determining if they are the ordered pair is a solution to that particular equation. Hope all goes well, and we'll see you tomorrow. All right, stop our sharing here. Remember, if you have questions, don't hesitate to ask.